Okay, Assalamualaikum. So today we proceed with the next topic, which is the coefficient of the partial determination. So actually this is the continuous from the topic extra sum of square before this. Okay, so kita baca sikit kat sini. Extra sum of square are not only useful for tests on the regression coefficient of a multiple regression model. Okay, as we know before this, we can use the extra sum of square to check whether the added variable will give the contribution to the model or not, and that new variable should be added or should be dropped from the model. Okay, but there are also encountered in descriptive measure of relationship called the coefficient of partial determination. Okay, recall that the coefficient of multiple determination, which is the R-square, measure the proportionate reduction in the variation of y achieved by introduction of the entire set of x variable considered in the model. Okay, as you know before this, R square adalah kita boleh tengok how many percent the total variation in y explained by the total variation in all the x variable. Okay, and then you also memorize that the formula for R square adalah SSR divide dengan SSE, kan? So ni formula untuk R square before this. Okay, so sekarang dia kata a coefficient of the partial determination in contrast will measure the marginal contribution of the x variable of the one x variable when all the others variable are already included in the model. So kita nak tengok macam mana how many percent the total variation how many percent when one x variable added into the model when the other variable are already included in the model. Kita boleh tengok berapa banyak dia punya contribution of that one new variable will give the contribution kepada y. Okay, when other variable are already included in the model. Okay, so ini contoh. Okay, contoh let's say kita nak cari partial determination of R square. Okay, dia punya notation macam ni. Tulis y, maksudnya kita punya model lah y. Okay, variable y tadi. Okay, 1 given 2 means that the x1 given x2 kat sini. Okay, so dia bermula daripada sinilah kalau kita buat. Okay, R square adalah SSR, kan? SSR divide dengan SSE. Tapi sekarang ini adalah partial determination. So, it is SSR x1 given x2 because of kita nak tengok partial of determination when x1 is added into the model while x2 is already in the model. So, kita kena cari extra sum of square SSR x1 given x2 divide dengan SSE untuk x2. Okay, SSE untuk x2. Okay, so how to find the SSR x1 given x2, which is the extra sum of square when we want to add x1, okay, given x2 is already in the model. So this is the formula yang you dah hafal sebelum ni. Kita boleh gunakan, we can use the formula of SSE ataupun boleh juga gunakan formula of SSR. Okay, depends pada the information that we have. Okay. So, kalau nak guna formula SSR, it will be SSR x1, x2 minus dengan SSR x2, you will have the same answer for the extra sum of square x1 given x2. So, let's say kalau nak cari R square x2 given x1, so dia akan jadi SSR x2 given x1 divide dengan SSE untuk x1. Okay. So SSR x2 given x1 ni adalah extra sum of square. So kalau you nak gunakan formula untuk SSE, so it will be SSE x1 minus dengan SSE full x1 x2 divide dengan SSE x1. Okay. Let's see pula kalau kita ada 3 or 4 x, okay, independent variables. But kita boleh tengok partial determination untuk one added variable saja. Okay, one added. Tak boleh nak check untuk kedua-dua terus. Kita boleh tengok contribution of one variable added into the model. Okay, at one time. Alright, so kalau kat sini kita ada altogether ada 3x. Tapi sekarang kita nak check contribution of x1. Okay, when x2 and x3 already in the model. So, kena cari extra sum of square. SSR x1 given, x2 and x3 already in the model. Divide dengan SSE untuk x2 dan x3. So, how to find all of this? Boleh guna formula and you can have the information from the ANOVA table. Okay, this one pun sama, konsep yang sama. So, it will be the extra sum of square. x2 given x1, x3. Okay. So, macam mana nak interpret this partial of determination? Okay, kita tengok kat sini. Okay, dia kata R square x1 given x2 measure the proportionate reduction in the variation in y remaining after x2 is included in the model that is gained by also including x1 in the model. Okay, kita boleh tengok the reduction in the variation in y remaining after x2 is included in the model. Okay, that is gained by also including x1 in the model. So, kita nak test, kita nak tengok berapa banyak contribution. Ataupun kita boleh juga interpret by tengok how many percent the contribution of x1, okay, or in y, okay, in the model, okay, when x2 is already in the model. Alright, look at the example. Okay, ini example daripada body fat example juga. Sebelum ni, the previous example kan. Okay, you can see page, okay, daripada awal hari tu, page 257. Okay, sekarang kita nak cari partial determination of x2 given x1. Kita nak tengok contribution of x2 when x1 is already in the model. So, kena cari extra sum of square x2 given x1 divide dengan SSE x1. Okay, so ini adalah extra sum of square. So, actually, didapat daripada mana? Yang ni. Extra sum of square, the formula it will be, kalau nak guna SSE, nak guna SSR pun tak ada masalah. SSE x1 minus SSE x1, x2. Divide dengan SSE of x1. So, mana dapat all this value? Daripada ANOVA table. Okay, you boleh check table 7.2, page 257. Okay, so yang ni pula, kita nak tengok contribution of x3 when x1 and x2 already in the model. So, kena cari extra sum of square x3 given x1 and x2. Divide dengan SSE untuk x1, x2. So, you will have this. Okay, kalau nak interpret of the R square kan macam biasa kita kena multiply dengan 100. Okay, so we see that when x2 is added to the regression model containing x1, okay, yang pertama tu, when x2 is added to the regression model containing x1, x1 dah ada dalam model, the error sum of square, which is the SSE of x1, is reduced by 23.2%. Okay. Okay, kita boleh interpret based on the reduction of SSE ataupun the increase of SSR. Remember? Okay, yang kedua pula, the error sum of square for the model containing x1 and x2, tu yang kedua, is only reduced by another 10.5% when x3 is added to the model. Okay, yang ketiga pula, if the regression model already contain x2, adding x1 will reduce the SSE for x2 by 3.1%. So, ini adalah contoh-contoh macam mana you nak interpret the coefficient of partial coefficient of determination. Alright? Okay, and then the other part adalah continuation daripada partial determination. We also can find the partial correlation, coefficient of the partial correlation, which is the value of R. Okay, the value of R. So, as you know, untuk dapatkan, macam sebelum ni juga, untuk dapatkan nilai R, we can square root the value of R square. Okay, the square root of the coefficient of R square is called the coefficient of partial correlation. It is given the same sign as that for the corresponding regression coefficient in the fitted regression function. Okay, coefficient of the partial correlation are frequently used in practice, although they do not have as clear meaning of the coefficient of partial determination. Okay, so contohnya, ini contoh yang sama tadi kan kita ada R square tadi. Okay, daripada this R square that we have, okay, kita cari the value of partial correlation R. Okay, bila you square rootkan all the value of R square, actually you akan dapat semua positif kan. Tapi actually the value of R, it can be positive or it can be negative. Okay, so how to know whether your R here sign-nya positif ataupun negatif? It depends pada coefficient. It depends pada coefficient. Okay, cuba tengok yang pertama. R x2 given x1, the square root of the R square. So the value is 0.482 and the value is positive, the sign is positive. So kat sini positif, macam mana you nak tahu ianya positif ataupun tidak? You can tengok dia punya coefficient. Okay, you can see the table 7.2. See on page 258. Okay, 7.2c, which is when we regress y on x1 dan x2. Sebab kat sini kan dia involve x1 dan x2. So you boleh tengok coefficient untuk C, 7.2C. So, dia punya value of beta 1 and beta 2 adalah positive. Both are positive. Okay. Okay. So, kat sini. So maksudnya kat sini kita test untuk, kita nak tengok contribution x2 kat sini. So, kita kena tengok beta 2. So, beta 2-nya positive. So, it will be positive here. Yang kedua, okay, yang kedua pula, ada 3 involve 3x. So, you need to see the coefficient when we regress y on x1, x2, and x3, which is table 7.2d. Okay, table 7.2d. Okay, sekarang kita nak tengok contribution of x3 kat sini. So, kena tengoklah x3-nya, beta 3. Okay, beta 3 coefficient untuk x3, which is the beta 3 adalah negative 2.186, which is negative. So, sebab itulah kat sini value R pun kita kena letak negative sign. Okay, yang ketiga, okay, kena tengok the same yang tadi, C. Okay, 7.2C sebab involve x1 dan x2. And then kita kena tengok coefficient untuk x1, which is beta 1, positive 0.2224. So, dia punya sign adalah positive. Okay, so that is how to determine whether your sign of the regression correlation, coefficient of the partial correlation, is positive or negative. Alright. So that's all untuk extra sum of square.